Today we're going to talk about 2.4. We're going to talk more about slope. The objectives here would be to find slopes in equations of parallel and perpendicular lines, interpret slope as rate of change, and find a function's average rate of change. So, if two non-vertical lines are parallel, then they have the same slope. Two distinct vertical lines, both with undefined slopes, are parallel. So, if you have the slope of one line, we call it M1. If the lines are parallel, the slope of the other line will be the same. If you were to look at this visually, it states two distinct vertical lines. So two distinct vertical lines, two lines going up and down. So this line and this line. These are vertical lines, these are parallel to each other. They have the same slope. Alright, so we're going to write the equation of a line passing through the point -2, 5, and it's parallel to the line whose equation is y is equal to 3x plus 1. We're going to write the equation in point-slope form and slope-intercept form. Alright, so let's look at y is equal to 3x plus 1. Let's determine what this slope is. 3 is your slope. Okay? So the new line will have the same slope, but it's going to run through the point -2, 5. Alright, so the new slope will also be 3. So let's go ahead and write it in point slope form. We know that it's going to pass through the point -2, 5. That's going to be my x1, my y1. So this will be y minus 5 is equal to 3 times x minus a -2. When we multiply this out, well, multiply this negative and this negative, that's a positive. So we get y minus 5 is equal to 3 times x plus 2. This is your point slope form. Now to get y by itself, first we are going to multiply out this right side. We get 3x plus 6, and now add 5 to both sides. Y is equal to 3x plus 11. So this is my slope-intercept form. Okay, in this next one, we're going to write an equation of a line passing through the point 1, 2, and parallel to the line whose equation is 2x minus 3y plus 5 equal to 0. We're going to write it in point slope form and general form. General form is this form: ax plus by plus c equal to 0. Alright, so first let's go ahead and figure out the slope of this line. The first thing I'm going to do is I'm going to subtract 5 from both sides. Then I'm going to subtract 2x from both sides. And then I'm going to divide everything by -3. I get y is equal to 2/3 x plus 5 over 3. The reason why this is positive, you have a negative over a negative. So this is your slope, the 2/3. So we know that our new line will also have a slope of 2/3, but it's going to pass through the point 1, 2. So this is going to be y minus 2 is equal to 2/3 x minus 1. Okay. This is my point slope. I don't have to break it down any further for point slope. But now let's go ahead and write it in general form. So what I'm going to do is, since I have a fraction here, I want to get rid of this fraction. So to get rid of this fraction, I'm going to multiply each term by the denominator of this fraction. So the denominator is 3, so I have 3 times y minus 3 times 2, and then 3 times 2/3 x minus 1. So what happens is this 3 would cancel out. So I end up with 3y minus 6 is equal to 2 times x minus 1. Go ahead and multiply this out. I get 3y minus 6 is equal to 2x minus 2. What I'm going to do is I'm going to bring these over to this side. Okay? So I'll have, oops, I'm going to subtract off 3y, and I'm going to add 6. So I end up with 0 on this side, and I get, this is a y, sorry. You end up with 2x minus 3y plus 4. This is a negative 2 minus 6. That's how I got the 4. So I'm writing it in general form. So the general form, I'm just going to switch everything around. This is the general form. All right. So the next problem is a U-try problem. I'm not going to work it out, but I'm going to put the answers up here. Your point slope form will be y plus 6 equal to 3 over 2 x minus 5. And then your general form would be 3x minus 2y minus 27 equal to 0. Alright, now we're going to talk about the slope and perpendicular lines. If two non-vertical lines are perpendicular, then the product of their slope is negative 1. A horizontal line having a 0 slope is perpendicular to a vertical line having an undefined slope. So basically, you're going to have slope of 1. If you multiply it with the other slope and you get negative 1, then your your lines are perpendicular. So if you look at the next part, it's a horizontal line, and if it intersects with a vertical line, those are perpendicular. So if you draw it, this is your vertical line, this is your horizontal line. What happens when two lines are perpendicular, they form a 90-degree angle. So that's what you get here. So I got this little box here that indicates 90 degrees. Now you cannot look at a graph and determine whether or not it's a 90-degree angle by eye, by sight. You can't do that. You have to have one of those protractors, whatever they call them, and then you have to measure the angle. But we're not going to do all that. So you just do it algebraically instead of looking at graphs. All right, so we're going to find the slope of a line that is perpendicular to the line, whose equation is x plus 3y minus 12 is equal to 0. Okay, so let's go ahead and figure out what the slope of this line is. First, you're going to add 12 to both sides. You're going to subtract x from both sides. You get 3y is equal to negative x plus 12. And then you're going to divide everything by 3. So you get y is equal to negative 1/3 x plus 4. So the slope of this line is negative 1/3. To figure out the slope of the perpendicular line, what you do is you take the reciprocal of this slope and then change the sign. So you take reciprocal of the old slope and change the sign. Okay, so if you guys don't remember reciprocal is this. You flip it. This is the arrow. So if you have negative 1 over 3, the reciprocal would be negative 3 over 1. And then you change the sign. So the slope of the line that's perpendicular to this one would be 3. So this is a U-try problem. The new slope, or the slope that's perpendicular to this equation here, will be negative 3 over 2. And you can try that one on your own. So now we're going to talk about how to write the equation of a line passing through negative 2, 3, and perpendicular to the line whose equation is 2x plus 4y plus 7 equal to 0. We're going to write it in slope-intercept form. Oops, sorry about that. Alright, so first we're going to go ahead and get y by itself here. So I'm going to subtract 7 from both sides. Next, I'm going to subtract 2x from both sides. Oops, what did I just do? Sorry. This should be... I subtract 2x from both sides. This should have been minus 7. That's what I meant to put. And now divide everything by 4. I get y is equal to negative 1/2 x minus 7 over 4. I just reduced that negative 2 over 4. So the slope of this line is negative 1 over 2. My new slope is going to be, you're going to flip it and change the sign. So my new slope will be 2. So now I'm going to plug everything back in to the point slope form, and then I'm going to get y by itself. So I get y minus 3 is equal to negative 2, positive 2. Two times x minus a negative 2. So that's y minus 3 is equal to 2 times x plus 2. Let's go ahead and multiply this out. We get 2x plus 4. And add 3 to both sides. I get 2x plus 7. Alright, let's try another problem. The graph of a function f passes through the point 6, 8 and is perpendicular to the line that has an x-intercept of 2, a negative 2, and a y-intercept of 4. Find the slope-intercept form of f. So, we know that the graph of f passes through the point 6, 8 is perpendicular to a line that has an x-intercept and a y-intercept. So basically we're going to use the x-intercept and y-intercept to find the slope because we got 2 points. So we have negative 2, 0 as the y-intercept, and we have 0, 4 as negative 2, 0 as the x-intercept, 0, 4 as the y-intercept. So we can go ahead and figure out the slope using these 2 points. This is a y. So we get 4 minus 0 all over 0 minus a negative 2. That will give me 4 over 2, which is 2. Okay, so the function f is perpendicular. So the new slope, the slope that will be for the function f will be, you're going to take the reciprocal of 2 and change the sign. So the new slope will be negative 1 over 2. Alright. So we know that the new slope will be negative 1 over 2 and it passes through the point 6, 8. So we get y minus 8 is equal to negative 1/2 x minus 6. We get y minus 8 is equal to, I'm going to go ahead and multiply out this negative 1/2. I get negative 1/2 x, and then half of 6 is 3. It'll be a plus 3. And then I'll go ahead and add 8 to both sides. 8 here, 8 here. I get y is equal to negative 1/2 x plus 11. The next problem is a U-try problem. This should be a comma here. And I'll go ahead and give you the answer. The answer is y is equal to 3x plus 2. The next one is also a U-try problem. And the answer here is negative 4x plus 3. So now we're going to talk about slope as a rate of change. Slope is defined as the ratio of change in y uh, to a corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. So let's look at this example. In 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. We're going to use this information to find the slope of the linear function representing adult man living alone in the United States. Express the slope rounded to 2 decimal places and describe what it represents. So we can get information from what they told us. We know that in 1990, 9 million men lived alone. And in 2008, 14.7 adult men lived alone. So we can figure out the slope from these points, these 2 points. Okay? So let's go ahead and write out the equation for slope. This will be 14.7 minus 9 all over 2008 minus 1990. I get 5.7 all over 18. That's 0.3166, which is approximately 0.32. I just rounded to 2 decimal places. So what does this mean? It means the number of men living alone increased at a rate of 0.32 million per year. The rate of change is 0.32 million men per year. Alright, the last page, we're going to talk about the average rate of change. We're going to let x1 and f of x1 and x2 and f of x2 be distinct points on the graph of a function f. The average rate of change of f from x1 to x2 is this formula. F of x2 minus f of x1 all over x2 minus x1. So let's figure out the average rate of change for f of x is equal to x cubed from x1 equal to negative 2 and x2 equal to 0. So the first thing I want to figure out is f of x1 and f of x2. Well, we know that f of x1 will be f of negative 2. I'm going to plug that in to the formula of the x cubed. So whenever I see an x, I plug in negative 2. I get negative 8. To calculate f of x2, I'm going to plug in 0, and this will be 0 cubed, which is 0. So now when I plug everything back into this equation here, I know f of x2 is negative 8, f of x1 is 0, I know x2 is 0, and I know x1 is a negative 2. Oh, wait a minute, I think I switched them. Hold on. I switched these two, sorry. This should be 0 minus, it should be 0 minus a negative 8. Sorry about that. So I get 8 over 2, which is 4. Alright, let's try another one. We want to find the average rate of change of f of x is equal to x squared minus x plus 4 from x1 equal to 2 to x2 equal to 6. Let's figure out f of x1, which would be f of 2. This would be 2 squared minus 2 plus 4. That would be 4 minus 2 plus 4, which is 6. Now let's find f of x2. That would be f of 6. I'm going to plug 6 back in. I get 6 squared minus 2 plus 4. I get 36 minus 6 plus 4, which is 34. Let's plug everything back in to our formula. I get 34 minus 6 all over 6 minus 2. That's 28 over 4, which is 7. All right, that's the end of this lecture.